Well, today I'm going to talk about a new topic, that is the relativistic addition of velocities. We are having two frame of references. This is one frame and there is another frame, right? It's like this, and one is the stationary frame and another is the moving frame of reference. So it is a stationary frame and it is a moving frame of reference, and say there is a particle in the stationary frame of reference, and this particle is moving in this way with the velocity u in arbitrary direction. And in stationary frame of reference, this particle p is represented by coordinates x, y and z, and in the another moving frame of reference means this is the moving frame of reference and it is moving along x-axis with velocity v. So when we are looking at this, then its coordinate seems to be like x prime, y prime and z prime. So say this is x-axis, so it is x prime, this is y prime, this is z prime, this is x, this is y and z. So this is the situation which we have considered. So now this is the arbitrary direction and the particle is at p and it is moving with velocity u in s frame. And now u can be written as because it has different components, ux, uy, uz. So ux can be written as dx over dt, it is dy over dt, and it is dz over dt. It can be written like this. But when it is seen from s prime frame, right, then velocities components will become ux prime is equal to dx prime over dt prime, uy prime is equal to dy prime over dt prime, and uz prime it's dz prime over dt prime. That's what we are getting here. Now let us recall this Lagrangian transformation. Lagrangian transformation. So when I recall those, then what I am getting, so that means this x prime is what? The x prime is equal to gamma x minus bt, and y prime is equal to y and z prime is equal to z, and t prime can be written as gamma t minus xv over c square. It can be written like this. So from here we can write down from here I can write down this dx. So if I take differential, then dx prime can be written as it is dx prime, it will become gamma dx minus v dt. This is one equation which I am getting, and dy prime can be written as dy and dz prime can be written as dz, whereas dt prime it can be written as gamma dt minus v dx over c square, right? So these are the four things which we are getting. So now I can write down ux prime is equal to dx prime over dt prime, and let me put their values. So if I put their values, then it is gamma dx minus v dt, that's what I am getting, and whole upon it's gamma dt minus v dx over c square. This value I have substituted from it, and this gamma will cancel out with it. So the value which I am getting, that is ux prime is equal to dx minus v dt whole upon dt minus b dx over c square. Dividing both sides by dt it will become dx upon dt minus v, right, whole upon 1 minus v dx upon dt and upon c square will be like this. So what is it? Dx upon dt is ux, right? So ux can be written as ux prime is equal to ux minus v over 1 minus v over c square into ux, right? So that's what I am getting for it. And similarly we can evaluate other things. Similarly, this uy prime can be written as dy prime over dt prime, and the value of dy prime will be dy as it is. What dt prime is nothing but it is gamma dt minus v dx upon c square. So it is dy upon, it is dt can be taken outside, so gamma, it is 1 minus v over c square dx upon dt. That's what I'm getting. So now dy over dt is basically uy, so it is uy over gamma 1 minus v over c square into ux, or it can be written as uy 1 minus v square over c square, because 1 over gamma is this one, so right, so 1 minus v over c square ux. That's what I am getting. And similarly we can write down expression for uz prime. So uz prime dz prime over dt prime. Similarly it is uz over gamma 1 minus v over c square ux, and is equal to uz 1 minus v square over c square under the root upon 1 minus uxv over c square over c square. That's what I am getting, right? So these are the results. So let me summarize these all. So all can be summarized as, let us summarize these results. So the value which I am getting is that ux prime is equal to ux minus v upon 1 minus vx upon vux upon vux upon c square. Uy prime, it can be written as it is uy, right, gamma 1 minus v ux upon c square, or it is uy 1 minus v square over c square under the root upon 1 minus v ux over c square. And similarly uz prime can be written as uz upon gamma 1 minus v ux upon c square is equal to uz 1 minus v square over c square under the root whole upon 1 minus v ux upon c square. So these are the three results which we are getting, and these are the equations used to find velocity of a moving particle when seen from moving frame of reference, right? So that's all for this. Now, and also let me write down their inverse transformations. So let me write down their inverse transformation. So it is ux can be written as ux prime plus b whole upon 1 plus vux prime over c square. Uy can be written as uy prime 1 minus v square over c square under the root upon 1 plus vux prime over c square. Similarly, uz can be written as uz prime 1 minus v square by c square under the root whole upon 1 plus v ux over c square, right? So these are the inverse transformations. So that's all for this lecture, and in the next lecture I will talk about the relativistic Doppler effect, right? So thanks for watching this lecture. If you find these lectures useful, then you can subscribe these lectures and press bell icon for new lectures, right?